My name's Austin Cheynet. I'm with AA Industries, and my teammates, Allie Townsend and Ann King, developed the VersaStand. The goal of the VersaStand is to tackle a common problem that many college students have, which is neck and back pain. I know myself, I experienced this due to leaning over, taking notes, and doing practice problems for hours on end, but it no longer has to be that way. Our team is developing a product that will not only help alleviate neck and back pain by providing a more ergonomic study solution, but will also provide a profitable product for VTEPs to invest in. First, in order to determine what our customers would need in a note-taking solution, we interviewed several of them and came up with the different needs and prioritized them through decision matrices. The main goals are the workspace size, so it can accommodate many tablets, the adjustability of the front hatch, and the overall form factor or thickness of the device so that it can be easily transported in students' backpacks. After completing our customer interviews, we moved on to our concept generation, where we broke all of the customer needs down into specifications and created our own drawings that meet different needs and specifications for the VersaStand. For example, this is the drawing that I developed, which includes a linear actuator with linkage system to apply for the most amount of angle range of the surface. This one was done by Ann King and shows a similar hinge design but with a different face and form factor. And this is Allie Townsend's design with suction cups and lip design to help create a more secure attachment for your device to your working surface. The VersaStand is unique and stands out from other patents. There are many other note-taking solutions on the market, but very few of them offer the same adjustability and ease as the VersaStand. The ease is done by creating an electric system that can open and close the device on command without the need for any hassle. During our design process, we needed to consider the FEA analysis, where we need to approach our product and see what possible modes of failure could come up, and also what actions need to be taken in order to avoid these. One example is the strength of the VersaStand and how much weight can bear down on it. So the item function would be the weight. The potential cause of failure would be stress due to compression in the linkages, and the recommended action for this is slightly thicker linkages with spacers and washers to help increase the overall rigidity of the linkage system. Here we have, after that, we brought our design from our sketches into CAD. This video on the left here shows a motion gen diagram of the linkages that we are trying to utilize for the most amount of displacement of the tip of the VersaStand. So taking our aforementioned needs, constraints, and failure possibilities, we developed the Versa stand using NX and CAD to not only assemble all the pieces for the Versa stand, but to be able to assemble it in NX so that we can make sure everything fit and that there wouldn't be any clearance issues, and to prepare our design for manufacturing. Okay. Utilizing the cost of materials for maximum profitability. AA Industries and VTEPs is a company, and companies need to make money. So we designed the Versa stand so that when it is manufactured, we'll be able to make the most amount of profit as possible. For the components of the Versa stand, we have a bill of materials right here, which include the costs and percentage of the total cost to build the Versa stand. And here is the economic graph for our Versa stand, which shows our break-even point and when we will be able to make our returns back. So a big priority in order to reduce the cost of manufacturing was to create the product in a way that it could be easily manufactured. A good example of this is for the base of the Versa stand, we chose to create an NX assembly with all 5 sides broken apart and then notches put into them so that they can be cut out on the laser cutter. And once they are cut out, they can fit together perfectly and can be easily glued or assembled by any technician in a small amount of time. We also worked with Proto Labs to receive a quote for our connector component, number 5 right here. There will need to be 3 of these for each Versa stand. Therefore, this will be a high quantity product that applies well to ABS injection molding. In order to get a quantity of 500, we are looking at a 2.29 cost per connector with a total cost of $7,000, including the mold for the injection molding. Yes, the injection molding will have a high initial cost, but due to the repeatability and low cost down the timeline, injection molding should work very well for this part to reduce manufacturing costs. So the AA Industries is finally been able to deliver a refined product. Here is our final prototype for the Versa stand. We laser cut it out of clear acrylic to be able to see the internals, and attached battery connectors so that it can be powered by a wall or a battery within the Versa stand. And it can be controlled with a joystick that allows you to not only control the speed, but also the distance of the actuation of the top lid. This photo here demonstrates the Versa stand in action with a writing tablet attached to it for note-taking or writing on. The next step to our process is enhancing the future versions of the Versa stand. The main components that we want to address in the version 2 of the Versa stand is confirming that there's clearance for the lid to shut completely, making sure the actuator speed is appropriate so that people can access their materials quickly, improve the fit and finish, and smooth all corners and make sure nothing's sharp. More secure, a way to lock it could be something that many people would value. And mounting the exterior joystick in a place that would not interfere with the user's operation. And all of these things combined with our current work would lead us to a final product that would be ready for production. Thank you so much. Have a nice day.